setjast niður og fá sér sæti. Fyrir þá sem hafa áhuga á því að þá mér sagt að inn á vef félagsumhverfisfræðinganna verði birtar glærur og upptökur frá fundinum ef það heppnast. Og vefurinn þeirra FUMÍ.is, FUMÍ.is. Þannig að einhvern tímann í dag og morgun eða svona bráðlega þá verði þetta nálgast glærur og upptökur frá fundinum í dag. En næstur Michael Bates, sem kemur frá School of Public Health við háskólann í Berkeley í Kaliforníu og bjóðum hann velkominn.
Thank you very much. It's a pleasure to be here. This is my first time in Iceland. I've wanted to be here to come here ever since I started investigating health effects of hydrogen sulfide. I'm originally from New Zealand, and I started my research in New Zealand when I lived there. But now I live in the United States, and where there's more funding available, which actually allowed us to do the study that I'm going to talk to you about today. So just a bit of background to start with. These are the acute effects of hydrogen sulfide, fairly well established, starting with just sort of odor effects, going through eye irritation, lung irritation, and so on, down at in the worst case to pulmonary edema, respiratory paralysis, and death. People often die very quickly. It's a highly toxic gas, acutely. But what's not so well known is whether it has any effects at long-term low levels. That's much less clear. And it was back as far back as 1981 that a World Health Organization committee recommended that somebody should study the conditions in a place like Rotorua, New Zealand. So just a little bit about New Zealand. It's comprised of two main islands. It's like Iceland in many respects. It's an isolated island country, and it's very seismically and geothermally active. And third, and particularly important, it has more sheep than people. So this is the North Island, and even though there's seismic activity right through, because it's the intersection of two plates, the main geothermal area is called the Taupo geothermal zone. And this is the city of Rotorua, which I'm going to be talking about our results in. So this is a picture of Rotorua on a humid day. And you can see that the geothermal activity is right through the city. Unlike here, where the main geothermal sites seem to be far away. Here, it's not power stations. It's, well, you can see this is the steam indicating where the geothermal sites are. So it's a major tourist city in New Zealand, and the Maori people settled here in about 800 years ago, and they've taken advantage of the hot water and everything. So in terms of geothermal gases, the things that are given off in geothermal areas, there are a number of things. The main gases given off are water vapor and carbon dioxide, but of course it's hydrogen sulfide. Most of these others are not so much concern. Mercury vapor, we've looked for mercury vapor and mercury in Rotorua, but we haven't found any. So I'm just really going to be talking about hydrogen sulfide today. So, okay, so some of the features in Rotorua, there's sort of boiling mud pools, geysers, and you can see the evidence of the sulfur around here, the yellow color. And boiling water pools used by the Maori people to cook their food going back centuries. And then there are less spectacular but important areas where H2S is emitted, and this is just around the shore of Lake Rotorua. So the city is on a lake which is an old volcanic caldera which hasn't erupted for about 100,000 years or so. And when the Europeans came in the 19th century, they recognized Rotorua for its spa potential. So this is the old spa building, which has been there since the early 20th century. It's still there. So anyway, now I want to start talking about our study. So the participants were 1,640 people. We selected from right throughout the city, and we deliberately selected them from areas which we believe to have high, low, and medium exposure to hydrogen sulfide, because everybody is exposed. You can smell it quite clearly when you come into the city. As soon as you arrive at the airport, you can smell it, and all around the city. Some places more than others, as I'll show you. So anyway, we had a clinic, and we invited our participants to our clinic, and where we put them through a number of tests. So our main study outcomes that we were interested in were these, and these were based on what we knew about the acute effects of hydrogen sulfide, and by scanning the literature to see what was known about H2S. We knew that it probably affected the nervous system and the respiratory system and the eyes. So we looked at these various things, and I'm going to show you a selection of results from these studies. I'm going to show you neuropsychological asthma from respiratory function. I'm going to show you some results for cataract as well. So this is some of our study team. So somebody here is doing one of the neuropsychological tests, groove pegboard. This is the interview, the questionnaire, which was electronically entered, directly entered, lung function, and we employed an optometrist who gave a fairly comprehensive eye exam, including taking photographs of the lenses. So now the questionnaire included a lot of things, the sort of things you'd expect, like smoking and drinking and so on. But very importantly for our exposure assessment, it included obtaining a full residential and workplace history, also going to school in Rotorua over the last 30 years. So also assisting us with our exposure assessment, we set out these radiello monitors. We put them out for 2-week periods, and then we collected them exactly 2 weeks later, and send off the cartridges to a lab, and it gives us a measure of the average concentration of H2S at that site over the 2 weeks. And we did this monitoring over several periods. So now I want to show you the results of some of the monitoring. And so this gives you a better idea of the geothermal layout in the city. So this is Lake Rotorua, the old caldera. These are the city streets. Now, up here is the main business area. Fenton Street, main business street, and down here is the big tourist area with geysers, and around here there's a lot of emissions from the lakeshore. So you can see, and this is from summer of 2010, and the circles are proportionate to the concentrations of hydrogen sulfide which we found there. And you can see that over here, in mainly residential areas, the circles are very small, indicating that there was not a lot of exposure. But there is a lot of exposure in this area where, as I said, it's mainly the business area. So we did it again in winter 2010, and superimposing the circles, the slightly lower concentrations, but nonetheless the pattern of exposure was identical, well very similar, I should say. And so what we then did, we undertook a process called kriging, which involved creating an exposure surface using the results that we'd obtained for summer and winter. And so the darker it is, the higher the concentration of hydrogen sulfide. And the yellow circles represent, and this is at the time of people's participation in the study, the yellow circles represent their workplaces. And so sorry, not circles, the yellow triangles, and the red triangles represent where they lived at the time. So you can see people may have lived over here in relatively low exposure areas, but come into work and got high exposure. So we had to take into account, when assessing exposure, both residential and workplace areas. So, so we created, for each person in our study, we created these individual exposure profiles by geocoding the addresses and taking the concentrations that we had and making some assumptions about, we collected information how long they stayed at work on an average day and so on. And we made some assumptions about how long they were at home. And we created a number of exposure metrics. So exposure metrics are basically sort of indicators of exposure. And so we did some for current exposure, so current being at the time that people attended our clinic. And so we had two there. One was a time-weighted average, taking into account hours at work and home and so on. And then we used maximum exposure. So we knew some people got their maximum exposure at work, some people got it at home. So we used that as another exposure metric at the time of participation in our study. And then we calculated long-term exposure using the time-weighted average approach, going back over 30 years, knowing where people worked and where they lived and went to school and so forth. So we have several measures of exposure. Now, so I'm going to show you results which involve splitting our participants approximately 400 in each quartile. These are 4 quartiles. So basically we rank them in terms of exposure, each of the different exposure metrics, and then we split them. And this actually just gives you the measures in pp, parts per billion. So I noticed that here people mostly use micrograms per cubic meter. To convert parts per billion into micrograms per cubic meter, multiply approximately by 1.4, and you'll get the equivalent level. So these were the levels of the concentrations, average concentrations in our different exposure quartiles for the different exposure metrics that we used. Now, first of all, I want to talk about the neuropsychological tests. And so I'm not an expert on neuropsychological testing. We had a number of specialists in each of the fields, and in this case it was Bruce Reed from UC Davis. And anyway, we subjected our participants to a number of tests looking at attention, and these are the tests. And neuropsychologists divide cognitive function into various domains: psychomotor speed, memory, fine motor function, and mood. And so I'm going to show you some of the results from that. So just to let me explain this, I have a number of slides which are in a similar format, and but so once you get the idea, you'll be able to see what it means. So this is quartile 1, the lowest exposure, and you can see for each of the 3 exposure metrics, the 2 current ones and the long term, these are like the average scores. So then the question is, what happens when you go across quartiles 2, 3, and 4 in an increasing exposure direction? And so this just shows the difference. And so you can see there's really no difference here, and this is the 95% confidence interval. And the better performance is indicated by greater than 0. So if it was more than 0, then it would suggest better performance. But most of these are fairly flat, particularly when you take into account the confidence interval. So that's digit span. So digit span is a measure of being able to remember digits and repeat them. They lengthen the number of digits until people reach their limits, basically, in terms of the number of digits that they can remember. And then there is a backward test, but it doesn't really give any results different to this. So then we had reaction time. And so people stared at this cross in the middle of the screen. This was using a computer. And then the bullseyes would appear suddenly, and then they would click the mouse, and it would measure their reaction time. Okay. So this is the results again, exactly the same format. And you can see, actually, interestingly, there is a better performance as less than 0. So actually, interestingly, there's a slightly better performance in the higher exposure quartile, but really when you compare it with the mean, it's not a great deal of difference. So there's not very much difference. So you might think of it as just flat, but interestingly, at least it's not worse. And then there's digit symbol, where people have to match up these symbols with the numbers here. They have to keep referring up and fill it in, and the number correct over a certain time. And then you can see once again, there's not a lot going on there. Better performance indicated by greater than 0. Actually, very slightly better performance, but nothing much in it. And this Hopkins visual learning test, which is a standard, fairly well-used neuropsychological test. Again, nothing much going on. And just to say, this is the Benton visual response test. Nothing much going on. Grooved pegboard. People have to put these pegs, which have a particular shape, they have to put them into these things. And so it's a measure, I think, of motor function, and measure how well they do there. Better performance less than 0. Really, I mean, nothing much going on there at all. This is tapping, so people tap a mouse, a high-performance mouse, with their finger over a certain time. How many taps can they do with their dominant and non-dominant hand? Again, we don't really see any effect or association with H2S. Also with the non-dominant hand. Okay. Now I want to move on to asthma. And this, in fact, these are the only results that have actually been published of these, the ones that I'm going to show you, but the others are sort of in progress. So we looked at asthma. We looked at the prevalence of asthma across the quartiles. Again, looking at quartiles, displaying it slightly differently. So this is the prevalence ratio. So the baseline was 1, and so then the question is, so 0.77 suggests there's 77% asthma in that in that next exposure quartile. So, and this is using the maximum exposure, whether it's work or at home, and this is using a time-weighted average. So if you look at this, you see that there appears to be a slightly better performance for current asthma, at slightly lower rates with the higher exposures. And again, for ever diagnosed with asthma, we also see slightly better, lower rates. This is for wheeze or whistling in the past year, which is an indicator of asthma. Again, it tends to trend downwards a bit. And same for shortness of breath when at rest in the last year. Except this one is pretty much flat. Woken by shortness of breath in the last year, again it's trending down slightly. And that one, woken by coughing in the last year, it's kind of flat, a bit wobbly. Woken with chest tightness in the last year. These are all, common symptoms of asthma. And we find a downward trending in the higher exposure quartiles. Now I want to move on to cataract. Some previous results suggest that cataract is more prevalent with H2S. So cataract is, this is a cross-section of the eye. This is a normal lens, which is clear. The light comes through here and impinges on the retina. A cataractus eye, there is some cloudiness and the light doesn't get through. Eventually, in the most severe cases, it can lead to blindness. So we looked at, we took photographs of the eyes and they were graded according to a well-known scale, the Locke scale. And I'm going to just show you the nuclear opacity, which is where the center of the lens becomes cloudy. And you can see on the Locke scale, which actually goes up from 0 to 7, it's pretty much flat. I mean, you could argue there was a slight downward, but it's hardly anything to speak of. And then there's a nuclear color. Unfortunately, because I prepared these this morning, I sort of debated with myself as which scale to show you. But this is nuclear color. It's going down very slightly. But if I showed it on the other scale, then you would see very little. It would be very similar to that. So no evidence there of a cataract effect. And we were looking there at the long-term exposure metric over 30 years. So with any observational epidemiology study, we have to be aware that there are potential other explanations. So it gets quite complicated going into these things, but we have been thinking about them. There's always the possibility of selection bias or information bias or confounding effect, being responsible for the results. We don't see any very obvious candidates for that, which is not to say that they can't be influencing our results. So the possibility, if we could exclude them, would be a real effect, but we can't really say, particularly with the asthma, is it a real effect? So anyway, our conclusions from that study, there's reassurance in that we don't see any harmful effects anyway. There is a suggestion that asthma prevalence and asthma symptoms decline as the hydrogen sulfide exposure increases. But on the basis of our one study, we can't really say that that will be the case. However, just to say that there is an increasing literature out there, and these mainly comes from people who are working in labs, usually with animals. And so they have shown that hydrogen sulfide is an important signaling molecule. There are 3 so-called gasotransmitters in the body: nitrogen oxide, carbon monoxide, and H2S. And they seem to have some important functions at low levels because they're produced in the body, and they can do these various things: relax smooth muscles and reduce inflammation. So both of these are effects that would be consistent with an asthma reduction effect. Can't say that that's really what's causing our results, but potentially it would be consistent. The increase in antioxidant enzymes in the body might be consistent with the very, very faint reduction in cataract we see, but it may not be any sort of real effect at all. Anyway, just to be aware that the literature is out there. They don't seem to interact with epidemiologists at all, so we haven't really had any overlap with these people. But when we found our results, particularly for asthma, we were perplexed, thought we'd maybe made some mistakes until we really found this literature, and it did seem that it might be consistent. So maybe there is, at very low levels of H2S, some beneficial effect, but it's much too early to say that. Because most of these lab studies have been carried on animals and very limited human data. So yeah, now because I'm aware that some of what I say may be taken out of context and used to prove the safety of H2S, I really want to make clear that we are a long way from that. So the key point is that any observational epidemiology study is potentially subject to various biases, which can be quite difficult to recognize and get rid of, particularly uncontrolled or residual confounding. And so we do not know, in our case, we cannot be certain that that is not going on. The results are interesting, but they really need to be confirmed in other settings by other investigators. And that's really important. And the other thing is that even if the results that we found are correct, there doesn't seem to be any harmful effects going on, they don't say anything about higher exposures. They say nothing. And they don't say anything about other health effects. They say nothing. So I stress this because I'm already aware that some industrial concerns that produce H2S have misused our results. So I'm trying to kind of guard against that. I think it's much too early to draw any definite conclusions. It's very important that we that other studies and other settings be carried out and see if the same results turn up. The problem is, of course, that there's not many large populations in the world exposed to H2S, and possibly Rotorua has the largest population, but I am hopeful that maybe we can discover a population in Iceland that has high exposure where some studies might be done. So just in concluding, to mention that there were many other people involved in this study, from the University of California, Stanford University, and the University of Otago in New Zealand, Auckland University of Technology, and so on. So I'm just kind of representing those people. And it was funded by the US National Institutes of Health under a particular grant. So that's it. Thank you very much.
Yes, thank you for a very interesting lecture. One question regarding effects of other pollutants, especially thinking about particulate matter. If you look at map...
So I have a few additional slides here.
Yes.
It wasn't set up.
Okay.
So because one thing we did not do was look at particulate matter. So particulate matter is inversely associated with H2S. So this is PM10 emissions estimated based on firewood used in Rotorua mesh blocks, which are like census units. So you can see that the concentrations here, which is not very residential, are quite low, but over here they're higher, and that's the residential area. And so the question could be, I mean, one question that we have, which is in our paper, is whether or not it could be that what we're seeing is not so much as asthma, it's not so much a protective effect of H2S as a harmful effect of particulate matter causing asthma. And we can't distinguish that because we didn't actually at the same time collect, we weren't anticipating this effect anyway, and we didn't think to collect particulate matter. But the literature is a little bit divided as to the extent to which particulate matter causes asthma and at what concentrations. So it's hard to say, but we do add that cautionary note in our publication about maybe it's a asthma causation effect by particulate matter rather than a possible protective effect like H2S. So we don't know. We hope to go back at some point and do further studies, in which case, knowing what we know now, we would collect comparable, hopefully, particulate data at the same time.
Is it my turn now? Thank you so much for an interesting lecture. Something springs to mind immediately. You said when you step out of the airplane in Rotorua, you immediately feel the sulfur in the air.
Yes. Actually, I
So-
felt that here too. At least I don't think I was imagining it.
So, but isn't the entire population then subjected to hydrogen sulfide all the time? They're all indeed, what shall we say, victims is probably a too strong a word, but they're definitely, you do not have within this population the control of people who have not been exposed long-term to low levels of hydrogen sulfide. Am I correct?
No, that's true, but there is a lot of variation in exposure across the city, as I
Yes.
and that's why we took into account home and workplace and school exposure. So, so we rely very much on the variation in exposure.
Right.
People are not equally exposed.
So the study really is on whether different levels of long-term exposure to hydrogen sulfide affect the parameters that you were measuring, but not really whether hydrogen sulfide in itself might affect the performance.
No.
For that, you would need someone who had not been subjected to these.
We assume that it's an internal comparison. So
Yes.
we have to rely on, we assume that some sort of, if there are effects at these levels, then we assume that there's some sort of dose-response relationship.
Yes.
And so that's what we're really looking to see. If
Right.
we use the population outside Rotorua, potentially it would be different in some other ways, and then you have
Yes.
that problem of, is it appropriate to compare Rotorua to another town?
But do you think it might be worth a study to see if they differ from other
It might
populations?
Be. It might be. We do hope to get some more funding to go back and do further
Yes.
studies. But there are, there's potential. There's always issues to comparing. There's no other obvious town unexposed to hydrogen sulfide which would make a convenient comparison with socioeconomic differences and so on. So we have to weigh those things up. We could if we had the money.
I definitely would be very tempted to encourage
Yes.
you to do that. Thank you.
Þórarinn Gíslason, I'm a lung doctor at Landspítalen, and I have to some extent been worried about this, what we call air pollution in Reykjavík, affecting 200,000 people living here, and in the next lecture you will hear why. So I'm wondering, when I hear your interesting data, how very well they are comparable to the situation in Reykjavík area. I'm wondering about non-response, how many did participate, and I'm also wondering about those individuals who through the years did have asthmatic symptoms. Didn't they simply move away? Did you do any attempt to see whether this is what we call a healthy worker effect, a healthy selection of a population that can run elsewhere? And finally, I'm wondering about whether the association of with like ozone could be the harmful effect that we are wondering about.
So I'm trying to think. So yeah, we had something like a 55% participation rate. We compared the non-participants, because we had some information on non-participants, with participants, and we found that there was a similar non-participation rate across the quartile, if you like. So we didn't see any evidence of that. And then the healthy worker effect is always something to be concerned about. We can't completely exclude that. I'm trying to think. I should have reread the paper before my talk. What did we do?
Did you look at those who were using anti-asthmatic drugs? Was there a higher prevalence among the non-responders? Did you look at those 30 years back that had been moving away?
No, I'm not sure that we did. There's always the possibility of some sort of selection process. But one thing to say, we talk to a lot of people, and there's no feeling amongst the people who live in the high exposure areas that they are being affected. In fact, the Maori people who kind of cluster around the high exposure areas, because they've lived there for a very long time, they would say to us they're completely convinced that this is of no concern at all. They welcomed us in, because we had to do a lot of community consultation, and so so there's no kind of belief system in the area that the higher exposure is a problem. Often there's sort of kind of folklore or whatever about the exposure effects, but there was nothing like that there at all. We talked to a lot of people.
Thank you. I a little bit missed it. How much do you really know about the almost half of the population that didn't participate?
What I can say is we know that in terms of sort of age, sex, ethnic group, and so on, that they were very similar. We did a comparison to see if there was any difference between the people who participated and the people who didn't. I mean, it was frustrating to us, but that's the best we could do, is get that number of people, 55%, I think, of the ones we tried to contact.
Thank you very much. I have just a couple of very short questions. One is, like if you have a steady exposure versus peak exposure, like we have here in the city, to people that have never been exposed to this, is it possible that that would have an effect? I grew up partially in a town called Hveragerði where there's a steady exposure, and so maybe it would be smart for the Icelandic people who want to study this further to do a study in Þorlákshöfn and Hveragerði, since they're relatively similar in size and so forth. And so I just saw that the population in Rotorua is 56,000 to date. So it would be very interesting to do studies in relatively small townships, like we have here in Iceland, and that are so close to also the exposure from the dam. No, not from the dam, from the geothermal area that is artificially done. So I have, and one more question: have you been to Hveragerði?
No. Yeah, I've only been in Iceland a couple of days, so I'm hoping very soon to go and visit some of these places and to see whether there are some exposed populations, because one of my objectives in coming here was to see whether there might be the possibility of doing a study a little bit like what we did in New Zealand, because on its own, with no other study, there's policymakers cannot really do anything about it. You really have to find the same sort of results in different places. Actually, if I could just go back to the question the gentleman over there asked about, what about the healthy survivor effect? Because I was trying to remember, I knew we did something. So what we did is we examined the four areas, the four quartiles, to see whether or not the residence time in those quartiles was different. Because we would expect that if people were moving out of the high exposure area because of they couldn't take the exposure, then we would see a shorter residence time as people came in and out. We didn't see that at all. We saw much the same length of residence in all four exposure quartile areas. So that reassured us that there probably wasn't a healthy survivor effect going on. You can never completely exclude it, but you know, we at least did that. We looked at our data in that way. So we don't think, well, at least we didn't